So on the first video, we discussed how to, and we practiced how to cross multiply to solve an equation where you had one fraction equal to another fraction. But if you have more than one fraction on the side of an equation, you could simply get rid of them one at a time by multiplying everything by the denominator of the fraction that you want to get rid of. Just like and actually guys, on your notes, change this to a 3. It says number 5 on your class opener. That was a typo. That should be a 3. Okay, so like on number 3 on your class opener, you got rid of the fraction by multiplying everything by the denominator. We're going to do that on this section also. Now I'm actually going to go over two different methods. One method is to get rid of all fractions at once. Another method is to get rid of one fraction at a time. Okay, so let me start with this one by getting rid of one fraction at a time, okay? So let's get rid of, which fraction would you like to get rid of first? This fraction or this fraction?
That fraction.
Oh, with the 3 over x? Okay, the 3 over x. How could I get rid of the 3 divided by x if I don't want the divided by x part? You're going to multiply by x. Now, it's appropriate to write that times x up on the top part. Do not write times x down here because it's really up here. I mean, if you wanted to get technical, you could put it over a 1, right? But anyway, you don't have to put that over 1. But the bottom line is, you multiply it by x, and what ends up happening is that this x cancels with this x. But it's not enough just to multiply one side of the equation by x. You need to multiply the other side of the equation also by x. So you're going to multiply the 1 by x, and even this fraction, 8 over x minus 5, you're going to multiply that by x also. So you're going to get rid of we're going to get rid of this fraction by multiplying everything by x. This times x, that times x, and that times x. Everything by x. My new equation will read x minus 8x, because 8 times x is 8x, over x minus 5, so you still have a fraction there that we're going to get rid of next, equals 3. Okay, now we want to get rid of that middle fraction right there, 8x over x minus 5. And how would I do that? I'd multiply everything by what? By the denominator, x minus 5. So I'm going to multiply this fraction by x minus 5, but I'm not only going to multiply that fraction by x minus 5, I'm going to multiply everything by x minus 5. This guy over here and this guy over here. Okay, so what ends up happening when I multiply this fraction by x minus 5, the x minus 5 cancels with the x minus 5. And I'm going to bring down what's left over, which is a negative 8x. That's what's left over. So bring down that minus 8x. And what happens over here? Well, over here you need to distribute x times x and x times negative 5. So x times x is x squared. X times negative 5 is negative 5x. And we already have that negative 8x that came down. We have the equal sign right here. And of course, we're going to have on the right side a 3x. I should probably do that in red. Oh my goodness, what just happened? Whoa, whoa. What am I doing? And of course, I'm recording all this. Yeah. So we have I'll leave it blue because this is messing with me. Sorry. 3x minus 15. I apologize for the multicolored equation there. Anyway, we want to move everything to one side. If I have a quadratic and it's an equation, I want to move everything to one side so I could set it equal to 0, so I could either factor, split, and solve, or maybe use a quadratic formula. So I'm going to subtract 3x. And actually, even before subtracting 3x, man, I'm really messing up on this video. Even before subtracting 3x, it'd be a good idea to combine this guy with this guy. And let me rewrite the whole thing. X squared minus 13x equals 3x minus 15. And now since I rewrote it, let me move everything over to the left side. I want to subtract 3x, and check it out, guys. I want to do 2 steps in one. I'm moving the 3x over, but I'm also going to move this minus 15 over by doing a plus 15. That'll cancel here, and I'm also going to add 15 to the left side, but I can't add it anywhere because there's no regular number. They're all terms of x. So I'm just going to put plus 15 over here also, even though there's nothing to add it with. But ultimately, it's going to become the new quadratic equation, x squared minus 16x plus 15 equals 0. Are you with me? So now I could either factor, split, and solve, or I could use a quadratic formula. And of course, I'm going to factor, split, and solve. What times what is 15 that if I add together is negative 16? Minus 15 minus 1. That's absolutely right. Which means that our two answers, if we were to use a zero product property to split and solve, our two answers would be what? Okay, and the only other thing to do is to check and see if 1 or 15 mess up the whole equation. And if you go back to the original, you'll see that 1 or 15 does not mess up anything, so both of those are our answers. So I hope we understand how we did this. We got rid of one fraction at a time. We started by getting rid of the 3 over x by multiplying everything by x. And then after that, we got rid of this second fraction by multiplying everything by x minus 5, x minus 5, x minus 5. That is one way of doing it. Getting rid of one fraction at a time. But that's kind of like doing baby steps, right? We could actually get rid of all fractions at once. Okay, so if you like getting rid of one fraction at a time, go for it. But we could get rid of all fractions at once by multiplying everything by the LCD of all the fractions. So if we take a look at this second example, we have x minus 3 here. Right here we have x squared minus 9, but that really could be rewritten to x minus 3, x plus 3. You guys agree? Yeah. Okay, so let me put a line through it. So when I try to think of the LCD, what's the LCD? And that is x minus 3x plus 3 together, right? Yes? Yeah. So you could get rid of all fractions by multiplying everything by the LCD. So this is another option, another way of doing it. So check it out. I'm going to actually put a x minus 3 x plus 3 right here. I'm going to put x minus 3 x plus 3 right here. Sorry, it's getting sloppy. I want to put an x minus 3 x plus 3 right there. And what happens is that all fractions will eliminate at the same time. If we take a look at this first fraction, you have an x minus 3 down there, and you have an x minus 3 up here. So you could just cancel those out. The x minus 3's cancel. Now, let me bring down the equal sign so nobody gets confused. What's left over on the left side? What is it? 6x plus 18, correct? And now, the middle fraction, this guy here. I have an x minus 3 that cancels with an x minus 3, even though it looks like an x dot 3. That's a minus 3. That cancels, and the x plus 3 cancels. So, in other words, the whole denominator cancels out, and what's left over? 8x squared. And how about that third final fraction? Well, over here, the x plus 3 is going to cancel with the x plus 3. And now here's the tricky part, guys. And remember, this is an x minus 3 in here. Here's the tricky part. This minus sign belongs, and I hope everybody's paying attention, the minus sign belongs to the 4x. So the minus sign belongs to the 4x. That's really a negative 4x. So when you distribute and you say negative 4x times x, that's going to give you a negative 4x squared. And when you say negative 4x times negative 3, that's going to give you a positive 12x. Are you with me? So do you see how we multiplied everything by the LCD and it got rid of all fractions at once? Some people don't like this because obviously it looks really messy up here. It's a lot of stuff that you're doing. If you want to get rid of one fraction at a time, go for it. But because, here's another option. If you want to get rid of all fractions at once, multiply everything by the LCD, and that's what will happen. Anyways, let's continue by solving this quadratic. I'm going to first combine like terms. I want to get 4x squared. I want to bring down the plus 12x. Bring down the equal sign, the 6x plus 18. So, ladies and gentlemen, because I have a quadratic, I know that I want everything on one side, so I could set it equal to 0, and then I could use the quadratic formula or maybe factor using Jaime Escalante method. So anyways, I want to do two steps at once right here. I want to subtract 6x, and I'm also going to subtract 18 and subtract 18. Once again, it's two steps in one. Don't mess up. I usually do. So this canceled, that cancels. What do we have? We have 0 equals 4x squared plus 6x minus 18. Now that is a quadratic trinomial equation. It doesn't matter if you have the equal 0 over here or if you just write it on this side. I like to have it on this side, so let's pretend that it's over there. Anyhow, I also notice that every single term on this equation is an even number. Now what does that mean? That means if I could divide everything by 2 just to make the numbers a little bit nicer. As long as you do it to both sides of the equation. So my new equation is 2x squared plus 3x minus 9 equals 0. And now at this point, you could either use the quadratic formula or Jaime Escalante method. But you know what? Even if it's not factorable, if you try Jaime Escalante and it's not factorable, you still have to solve it because you might end up with irrational answers, maybe like with square roots. So it's always a good idea to use the quadratic formula. And that would be x equals negative b plus or minus square root of b squared minus 4ac divided by 2a. Also, when you use a quadratic formula, it'd be a great idea to plug it in with parentheses. And there's a quadratic formula with parentheses instead of letters. I apologize for it being so ugly. Anyway, we're going to plug in 2 for A, 2 for A, 3 for B, and negative 9 for C. And if we start working on the quadratic formula, you'll have negative 3 plus or minus the square root of 9 plus... And if we continue working, we'll end up with negative 3 plus minus square root of 81 over 4. And that's really negative 3 plus or minus 9 over 4. And that's really, that's really going to be negative 3 plus 9 over 4 and negative 3 minus 9 over 4. And that's going to give us two answers, which is 6 over 4, and over here, negative 12 over 4, which finally gives us 3/2, because that reduces by 2, and over here, negative 3. So you get two answers, 3/2 and negative 3. Now, if you put both of those answers on your test, it's going to be wrong. Because if you go back to your original, the negative 3 will not work because it would make this fraction undefined. Which means that negative 3 is not part of your solution. It's an extraneous solution. So the only real answer that you have is the 3/2, not negative 3. Do not write down negative 3 as your answer.